Welcome to the sun today for the 28th of February 2022. We're going to talk about spotless flares today. But first, let's go over what's happened in the last 24 hours. From panel 1, you can see that the sunspot number has suddenly increased to about 55. In panel 2, it shows that geospace, the magnetosphere, is relatively quiet. We did have a disturbed period yesterday, but that came to nothing. The solar wind has actually increased to 520 kilometers per second, so this situation may not remain so for long. In the third panel, we can see the sunspots. We still have regions 2954 and 2955, but we now have two new regions, 2956 and 2957 numbered. The region in the northeast, circled in green, is actually showing signs of strong growth. In panel 4, we can see the GLOW's X-ray plot, and we had a C3 flare this morning, and in fact that is going to be the subject of today's video because it is what is called a spotless flare, i.e. it came from a region with no sunspots. We've had 79 days since the last spotless day, and so with that C flare this morning we've had 2 consecutive days with a flare C1 or greater. What is a spotless flare? There's an example of one on the right here. This was a fairly large one, an M flare. Flares come from the release of stored up magnetic energy. In order to store energy, the magnetic fields must be stressed and they must be strong. The stronger the fields, the more energy, the more stressed they are, the more energy there's in the fields. Sunspots are areas of strong magnetic fields, and their dynamics cause the fields to become stressed. So the vast majority of flares are associated with sunspots. The exception to this rule, of course, is filament eruptions, which can produce fairly strong flares in their own right. To establish whether this was a spotless flare, we've got to establish there are no spots. On the right, we have a picture of the flare itself, and you can see it's a fairly large area of flare, just near the southeast limb. If I take the same box and put it on an optical image of the sun, you can see no sunspots at the site where the flare is occurring. The spots in the area are way up north here. I've circled them with this blue circle. This bright area here, though, is interesting. It's called Plage. So we've put a name to this structure, Plage. What is it? Actually, it's the French for beach. Not quite sure why we're calling areas on the sun beach, but nonetheless, that's what we've done. These are bright areas in the photosphere. They're in fact the exact opposite of sunspots. They are areas that are hotter and brighter than the sunspots. And one of the things you can see from this picture on the right is that the areas of Plage are quite large. There's Plage all the way through the network of the solar surface, plus there's concentrated areas anywhere near where sunspots are. And in fact, the area and the brightness of the Plage more than compensates for the darkness of the sunspots. So we have actually here the reason why at solar maximum the total solar radiance is higher than solar minimum. You would have thought when there's a lot of sunspots around, the total solar radiance would drop because there is less energy coming from the sunspot areas. But there's more than compensated for by the Plage. The flare side is even brighter, so let's take a closer look at that. So here is the blow up of that little section down in the bottom left there. And you can see there's 2 bright flare kernels just there. That's the flare site. So you can see it's well away from the sunspots to the north. Well, the next question then is, was there a filament eruption? Now, if you look at the helium-2 304 images, you can certainly see a lot of dark areas at the time of the flare, the bright area in the middle here, but none of them seem to be erupting at this particular. Some of these filaments did erupt a little bit later, but that's already after when the flare occurred. So what conclusions can we draw from all of this? This was genuinely a spotless flare. There were no sunspots in the area, and it wasn't a filament eruption. Why did we get a flare? There's 2 possible regions. This is new magnetic fields emerging from beneath the surface of the sun, so the likelihood that we'll start seeing some spots in the area in the coming days, or is old magnetic field rearranging itself as it decays, producing a flare. We'll have to wait and see which it was. So thank you very much for watching my video. If you liked it, please pass it on to others who might enjoy it. In the meantime, stay safe, and until next time, goodbye.